Hey everybody, welcome back to Mr. A's Geometry course. Today we're going over compositions of transformations, which is just performing more than one transformation on the same graph. So if anything, this is just a great review of all the rigid transformations that we've learned so far. Let's get into it. We're gonna start here with just the basics of naming our figures when we're doing compositions of transformations. So we still have an original figure called our pre-image. That'll be our purple A right here. And after a first transformation, we would have our image A prime, which we're used to after one transformation. But then once we take that new image A prime and transform it again, now it becomes a double prime. That's how we pronounce that with that double apostrophe there. We would say double prime. All right, that's our naming for compositions of transformations. Very important note here, when we're doing compositions of transformations, we must do them in the order that they are given to us. Okay, so for example, in this first example here, we have triangle ABC as our pre-image. We're told to do two transformations with it. The first one that's being given is a translation. We must do it in this order. Do that translation first, then the reflection afterwards. So just to review a function notation here with translations, this tells us what distance and what distance and what direction to slide. X plus 6 would tell us to go to the right 6 units. Y plus 2 tells us to go up 2 units. So we would just do that carefully, 1 point at a time. Starting with point A, if I go right 6 and then up 2, that would give me A prime at positive 8, negative 1. If I do the same thing with my point B, going to the right 6 and then up 2 will give me at 0, negative 5 for point B. That'd be B prime, I should say. And then same thing with point C, to the right 6 and then up 2 would get me to negative 2, negative 1. That would be my point C prime, and there is my first image after my translation. That's ABC prime. Now we go to the second transformation that's being asked of us, which is the reflection over the y-axis. And again, we're taking our most recent figure to do this. So that original pre-image doesn't matter anymore. I'm reflecting ABC prime over the y-axis. Again, doing this just 1 point at a time. Remember, for these flips, our pre-image and our image will always be equidistant from the line of reflection. So we're just flipping the points the same distance to the other side of the line in this case being our y-axis. So I can count horizontally how far away A prime is. That's 1, 2, 3, 4, 5, 6, 7, 8 units away from my line of reflection. So A prime is also going to end up 8 units away to the other side. 1, 2, 3, 4, 5, 6, 7, 8. And I should have said A double prime. So after my second transformation, I call that double prime now. B prime is on the y-axis, so its reflection is going to remain on that same location. There's B double prime at the same place. It's a little review there. If your point's on the line of reflection, then it'll stay on the line of reflection after your transformation. C prime is 2 units to the left, so if I count the same 2 units to the other side, I'll be able to graph C double prime right there, and I'll do this one in a different color here, just so that it sticks out for us. There is ABC double prime. It's very common when we do these compositions of transformations for our graphs to look a hot mess like this with just overlapping figures. But again, we're just going to take it one transformation at a time, 1 point at a time to do composition of transformations. Just as we're going to be expected to perform compositions of transformations, we also need to be able to describe compositions of transformations. So we have here on this graph 2 transformations that have occurred. We have to describe both in the order that they happen, which means we need to identify the pre-image. As we look at our triangles here, we have like a light blue, a reddish, and a brown triangle. And we can identify the original figure as the one without apostrophes, and that would be this triangle here. We can identify the first image as the triangle that only has 1 apostrophe, which would be this triangle, right? And hopefully you can identify that as a flip. This shape has just flipped down to this location. Remember, that type of rigid transformation is called a reflection. And if it's ever not obvious what our line of reflection is, remember that you can just find the midpoints of all of your corresponding points, and they would be on the line of reflection. For example, the midpoint between C and C prime would be right here at 2, 0. The midpoint from B and B prime would be right here at 1, 0. The midpoint for A and A prime would be here at 5, 0. If I connect those, that would give me my line of reflection. That is the x-axis. So that first transformation is a reflection over the x-axis. Remember, once we've identified the first transformation, that original figure no longer matters. We are only looking at our newest figure to describe the next transformation. So pre-image now doesn't matter. We're now figuring out how we get from the red triangle to our brown triangle. And hopefully you recognize that's just a slide to the left. That's a translation, right? So the type of transformation here is a translation. And then we just need to come up with the rule for that translation. As a reminder, with translations, we can describe them with words, with vectors, or with function notation. For this, I'm going to give you both the vector and the function notation, as I'll be verbally explaining the rule here. To get from A prime to A double prime, we notice that we're just going left 1, 2, 3, 4, 5. From C to C prime is also left 5. B to B prime is also left 5. We're just sliding to the left 5. As a vector, to write that, remember we have these arrows. And then left 5 is just going -5 on our x-coordinate and then not changing anything for our y-coordinate. So that would be our vector for that translation. For function notation, which is the one you probably need to understand the most, we would say xy becomes x minus 5, that's going left 5, and then y stays the same. That is describing a composition of transformations. Again, this is really just a review of everything we've gone over and just understanding that we can do more than one transformation on the same graph.